Hey everybody, this is Mr. Beckstrom, and this is the problem that I was doing during my office hour, and I kind of messed up part of it. So let's go ahead and just kind of start from scratch and see how to solve this. It says a rectangle initially has dimensions 2 centimeters by 4 centimeters. All sides begin increasing in length at a rate of 1 centimeter per second. At what rate is the area of the rectangle increasing after 20 seconds? Alright, so the sides, the length and the width, they're both increasing at a rate of 1 centimeter per second. So we can write that as the change in width with respect to time, dw over dt, that's going to equal 1. Also, the change in length with respect to time is also equal to 1. And then we want to know what is the area of the rectangle, or what is the rate the area is changing after 20 seconds. So let's draw our rectangle here. And so initially the longer side was 4 and the shorter side was 2, but it's been 20 seconds and it's increasing 1 centimeter per second. So both sides have gotten 20 larger. So that means the longer side is going to be 20 plus 4, which is 24, and the shorter side will be 20 plus 2, which is 22. And we're trying to find how the area is changing with respect to time. That's our unknown here. Now our objective function is area is equal to length times width. And I was initially thinking we needed to use the perimeter in order to get this in terms of one variable. But the problem with that is that we need both of these pieces of information. We need the change in width with respect to time in there and the change in length with respect to time. So let's go ahead and just keep it like this right here. And we can, when we use implicit differentiation, we can use the product rule. So this is going to be dA over dt is equal to, this will be the first term here times the derivative of the second. So times the derivative of the second, the derivative of w is just 1, but times, since we used implicit differentiation, we need the dw over dt there. And this is plus, and we do the second one, w times the derivative of L, which is also just 1 times, since we took the derivative of the length, we need to do the dL over dt. And then we get this equation here. And this uses both our dw over dt, which we know, our dl over dt, and we know the length and the width here. So this should just be the length, which is 24, times 1 times dw over dt, which is 1. So that's just 24 plus 22 times 1 times 1. So that's going to be 22. 24 plus 22 is 46. So it's increasing at 46 centimeters squared per second as the rectangle gets this large. So once again, the issue I had earlier where I tried to get this in terms of one variable, then it leaves out a key piece of information because I either going to solve for width or length, and then I'm leaving out one of these, so it makes it seem like it's only getting bigger in one direction. All right, if you have any questions, please let me know, and I hope you have a great test.